perfectly correct the square root. So this is problem 127, and it's on page, what page? 296. And we are given a function exactly what you recommended, 2.9, the square root of x plus 20.1. Excellent. And as expected, there are some transformations in there. It says models the median height. So this, I take notes, median height. In inches of boys who are X month of age. X months. Perfect. The graph of the function is shown. I see it. Describe how the graph was obtained using transformations. Very nice. How was it obtained? Step number 1, we thought of the square root. After we plotted the data, we thought immediately of the square root. Then we applied the first transformation, which is a vertical stretching, because this number is more than 1. Vertical stretching. Let me write. Let me not be lazy. Vertical stretching. And then 2.9 the square root of x plus 20.1. Up 20.1. That's our explanation. We can easily see that. Part B. According to the model, what is the median height of boys who are 48 months or 4 years old? Okay, so for 48, I'm really asked to find f of 48. Good. Where's my calculator? Here it is. I recommend let's put it in y equals 2.9 times the square root of x and plus 20.1. With the second and table, I would plug in 48 months and I get 40.12. 192, sorry, 192 inches. Okay, so let's see what they want next. Any questions for me, anyone? Thank you, Erin, I saw that. Thank you, Mark, I saw that. Just saw that. Okay. The actual median height for boys at 48 months is 40.8. So this is given by the model, given by the function or the model that they fit. Actual is 40.8. 40.8, yes. And the question is, how well does the model describe the actual height? Are you happy with the answer? So this is the actual from the data set is 40.8, but we from the calculations plugging in the model, we got 40.19. Are you happy with the answer? Do you think that for 48, I don't know for any other any other age, but for 48, by comparison, would you say that the model is good? It predicts close. It cannot predict perfectly, but it's pretty good for 48 months. Model is or is not good? What will you say? 40.2 and 40.8. It works or not?
Yeah.
It's good, very good. Yes, model is good. For 48. If you ask me for 21, I don't know. I haven't checked. But for 48, it's good. Part C. Use the model to find the average rate of change in inches per month between birth and 10 months. So, next question. Average rate of change between birth and 10 months. And the last question, use the model to find the average rate of change in inches per month between 50 and 60. Fine. The average rate between 50 and 60. So I want to mimic the graph here because I like us to discuss one thing and then we'll move on. So 10, 20, 30, 40, 50, 60, 70. 10, 20, 30, 40, 50, 60, 70 months. And this is f of x, height. Okay. So between 0 and 10, between 50 and 60. How do I determine the average rate of change? You had that on the test too. So how do I determine the average rate of change for any function between 2 points? Anyone? Can anyone give us the formula? F of 10 minus f of 0 over 10 minus 0. F of 60 minus f of 50 divided by 60 minus 50. Now, here's the slope, here's the line through the first 2 points, and here's the line through the second pair of points. Which of these two do you think is higher? Which rate of change will be higher? The one between 0 and 10 or the one between 50 and 60?
0 and 10.
Of course. Look at the slope. And look at the slope. Very good. I'm going to plug in the numbers in the calculator. We have the function already. So go to second and table and plug in the rest. 0, 10, 50, and 60. So between 0 and 10, I got for 10, 29.271 minus 20.1 divided by 10, which is 9.1, so 0.91. Measurement unit, please, and the average rate between 50 and 60. I got for 60, 42.563 minus 40.606 divided by 10. Okay, so measurement unit for 0.91. And then 42.563 and subtract 40.606 and then divide by 10. I shouldn't do this with a calculator. And this is 0.196. Okay, so measurement unit for these two. The rate of change has two measurement units, one coming from the top and one from the bottom. So, what do you think? What do we measure the top variable by? We measured it by. Or what's measured in? Anyone? So that was inches, and this is month. So the average rate of change between 0 and 10, as expected, much higher than between 50 and 60. And actually, it's almost, so if you consider this 1 and 0.2, 5 times as much. Okay, any questions? Any questions? Okay. so let's move on then. The next item on our list is, I think that's 11, yes. 2.6, Algebra of Functions and Function Composition. So what happens here is when we want to, let's say, add or subtract or multiply or divide functions. Add, subtract, multiply, divide, but this time functions. I did not mention function composition here. So the algebra means addition, subtraction, multiplication, division of functions. Let's suppose I have two functions. Here is one. And I'm going to call it f, and this one is g, and I'm going to come up with some numbers. I'm going to say that this is -4, I'm going to say that this is -2, I'm going to say that this is 4, I'm going to say that this is 8. And I'm going to ask you what is the domain of f and what is the domain of g. Can anyone give us the domain of f or g or both? Anyone?
-1 to 4.
Thank you very much. Very good, awesome. So when I say create the function that adds these two functions or subtract these two functions, etc., this is what I really mean. And this is self-explanatory. This is the name of the function of x. F minus g, this is the name of the function of x. Fg of x and f over g of x. So if I ask you, find f plus g of x, you know what to do because the name tells me or tells you to add those two functions. If I give you two functions, f and g, and I say, please find f minus g, you will know how to find it. Because the name is self-explanatory, it tells you what to do with those functions. Same thing here, it tells you what to do with those functions. Same here, it tells you what to do with them to create it. However, this one has an if. How come that these did not have an if, but this one has an if? And what is it for? Why do I need an if in there? Can anyone tell us why I need an if, but I didn't need it when I added, subtracted, or multiplied, but I need it when I divided? And what does it mean? Anyone?
Conditional.
Because g of x cannot be 0. We cannot create a function if its denominator is 0. So now you can say, what's all this? And how do you connect them? Very important. Let's suppose I have these two functions. I'm coming back to it, to the graph, and I'm asking you to find f minus g of 10. You could say that's very easy. It's f of 10 minus g of 10. True, but they don't exist. F of 10 does not exist. G of 10 does not exist. So, what's with all that? Well, the key is what is called common domain. This is a key concept. So I can ask you to find these functions, but not just everywhere I want. But where? For this particular example, for this graph, Where can I ask you to determine or evaluate the sum, the difference, the product, and the quotient? Where is the common domain of these two functions, where they both exist at the same time? Because if one or the other or both don't exist, this makes no sense. So where will it be in my graph, in this particular example, where will it be the common domain? CD, common domain is?
-2 to 4.
Excellent, thank you. So if I want to ask you to determine any of this, I have to stick with -2 to 4. I can ask you to find the function, that's fine. But if we don't have the function and we only have the graph, I can only ask you to find f plus g minus g product quotient only between -2 and 4, where both functions exist. Otherwise, what you want to create is undefined. Okay, so one very important example here is when we are asked to find common domains. It doesn't say it like that, but that's what it means. So I'm going to start with 26 on which page is this? 310. 26 on 310. And that is a function f of x equals the square root of x minus 3 plus the square root of x plus 4. So this is like saying I'm adding two functions. I have to determine the domain of the first one. I have to determine the domain of the second one. And if there is no overlap, there is no function. So can anyone tell us, and we had several examples today, how do I start? What do I have to write in order to find the domain of this one? And what do I have to do? What do I have to write to find the domain of this one? What do I have to write? Anyone?
So the domain for the first one.
No, you cannot state the domain. You can only give me what I have to write to eventually find the domain. Do not state the domain. I have to write something that will give me the domain for everyone to see.
To the right 3, the left 4.
Say it again.
To the right 3, to the left 4.
We're not looking at transformations, and we're not looking at anything else but this function. What do I have to write in order to find its domain? We wrote it many times today.
3 to 4.
Greater than or equal to 0.
Thank you very much. This is the condition that I have to write for the existence of this function. When I solve, I get 3 to infinity. This is the domain of this function. Now let's forget about that function. What do I have to write for this one?
X plus 4 is greater than or equal to 0.
Excellent. Which means this, which means this. Great job. Now, I will graph both because I need to find the common territory. Common domain, where they both exist at the same time. So this one is from 3, a bracket, to infinity. The other one is at -4. Notice I don't care for units. This is just helping us find the interval. Can anyone give us the common domain? One more time. The common domain. Say it again.
-4 to 3.
One more time. The common
Positive infinity.
Common domain is where both colors exist, only one color here and no color here. Common means both colors at the same time. Very good. Is that clear? If you choose a value here, one or the other will not exist. But if you choose any value here, both of them will exist, and you will get numbers and you will add them. Okay, let's look at another. And then move on to create those functions and function composition. Let's look at 28 on the same page, 310, and that is g of x equals the square root of x minus 3 over x minus 6. So this is, first of all, it's a ratio. Secondly, it has a square root at the top. So let's start with the ratio. Forget about the square root for a moment. Now tell me, what condition would you have to write right away? Anyone? We've been discussing this since the first day of classes when we solved rational equations.
The bottom can't be 0.
Excellent. That's all I need for now. Perfect. Great job. Now let's go to the top. The top is a square root. We may run into problems. We had an example less than a minute ago. What is the condition that I have to write so that that radical exists?
X minus 3 is greater than 0.
Or
Greater than or equal to 0.
Excellent. These are the two conditions that we have to solve. Clearly, this cannot equal 6. X cannot equal 6. This is clear. From here, when I solve this, I get 3 to infinity because it has to be greater than or equal to 3. I will graph just to make sure that I am choosing the correct domain. I will start with 3, bracket to infinity, and I will have to exclude 6, not 6. Therefore, the domain of this function is, and what do I need to write?
Would it be 3 to 6 and then 6 to infinity?
Excellent. This is the domain of this function. Excellent. Any questions? Please stop me. Anyone?
I got a question.
Please.
For the My Labs assignments,
Yes?
can you change the date on the 2.5 homework?
It's already done.
Thank you.
Thank you. My apologies. Okay, so we're given, let's say, problem 38 on 310. F of x equals 5 minus x squared, and g of x equals x squared plus 4x minus 12. We're asked here to find all functions, sum, difference, product, and ratio. So we're asked to find f plus g of x, which I have to write a definition, is f of x plus g of x. I copy f of x, plus I copy g of x. Combine like terms, I get 4x minus 7. This is the sum of those two functions.